Hi, and welcome to podcast number 16. We're getting closer to the end. All right, I lied at the end of our last podcast. We're actually doing weak acid, strong base titrations first, not strong acid, weak base titrations. All right, now, these are going to have a few different rules along with them, and so we need to pay close attention to how they differ from strong acid, strong base titrations when you are working these up for homework or, more importantly, probably exams. Well, here we're going to look at a titration curve for a weak acid, strong base titration. Notice that in this case, right, we're going to still start acidic, but we're not going to start super low like on our strong acid, strong base. Remember, we were way down there starting out. All right, so in this case, yeah, we're still acidic, but we're just a little bit higher up. All right, so in my example here, I have some acetic acid, right, reacting with a strong base, which we're showing as OH, to come to equilibrium with the acetate anion and water. All right, so again, if I want to find the K for this reaction, notice that the K for this reaction is 1.8 times 10 to the 9th. Still big, right? It is not as big as it was for strong acid, strong base, but for the most part, this is a pretty gosh darn big K value, meaning that when I add these two things together, it is going to basically go to completion. Okay, so notice then that we are going to start to go up our curve, right? We're going to go up our curve here, we're going to flatten out a little bit, and then we're going to reach here, and as we near our equivalence point, right, and notice that the equivalence point is on the sharpest part of this up and down area here, somewhere in the middle of it. And so you just kind of eyeball it, right? And so we're going to say somewhere in there. All right, notice a couple of things that are marked on here. Number one, it has our equivalence point, and number two, it has the half neutralization. All right, now for a weak acid, strong base, notice that the equivalence point has a pH greater than 7, right? When it was strong acid, strong base, it was right at 7. So we would just write down 7 if we had that as a question. Here, we must calculate this. And we're going to see how to calculate these before we get done with this chapter. All right, but we have to calculate it at the equivalence point. Now, at what we call half neutralization there, or 1 halfway to the equivalence point. All right, and so notice what I'm saying there is, like, say that the equivalence point happens at when we added in 50 milliliters of NaOH, then half of 50 would be when we added in 25 mils. So halfway to us having the same number of moles of acid and base, right, which is what we're going to call the 1/2 equivalence point. All right, the pH is equal to the pKa of our weak acid. All right, and so in this case, it would be the pKa of acetic acid, which we could look up. All right, so again, we can look back and we can look at our titration curve there and notice that the pH starts out above 2, right? It's still low, it's still below 7, right? But notice that the pH does start out above 2, and then it starts to rise up a little bit. And so notice that we can find out that it was starting with a weak acid because of this. All right, and then it says that the pH rises slowly until the equivalence point is approached. All right, notice here, and I'm going to point this out on our next slide. It says that the region between the beginning and the equivalence point is actually a buffer system. And we probably didn't notice it on that slide. But if you look at the beginning of the titration curve, it looks a heck of a lot like when we had buffer capacity. So look back. at the buffer capacity curve, it should look like that area. All right, we're going to do this calculation, though, as we go along on our next slide. All right, and then at the equivalence point, right, we have a solution of a weak base, so the pH is greater than 7. And then after the equivalence point, we're just dumping in more and more strong base, and so the pH is going to rise after that. Let's take a look at what is happening before the equivalence point. All right, if we want the pH, right, before titrating, all right, what we're going to do is the only thing in our beaker is a weak acid. All right, if I wanted to calculate the pH before any titration, we're going to do, this is a weak acid problem. All right, the pH at the equivalence point, or sorry, at 1/2 the equivalence point, is equal to the pKa of our acid. All right, why? And why do we have a buffer system then? Alrighty, well, let's take a look at our reaction. All right, we've got our acetic acid. We're going to react that with some strong base, and we are going to form the acetate anion, like so, and some water. All right, so at 1/2 of the equivalence point, all right, recall, at the equivalence point, the number of moles of our acetic acid is going to equal the number of moles of the strong base. So, right, at the equivalence point, the number of moles of my reactants have to equal each other. All right, so let's say that I had, right, 1 mole of acetic acid. All right, at the equivalence point, I would have 1 mole of hydroxide, right? But so halfway to the equivalence point, I would only have 0.5 moles of hydroxide, right? I would have half as much halfway to them being equal. So the change would be that these are both going to go down by 0.5, and the acetate anion is going to go up by 0.5. So we're going to have this halfway to the equivalence point. Notice that I'm going to have a weak acid and the conjugate weak base. This is, number 1, a buffer. All right, now we can also then calculate, right? And we could say, okay, well, the pH of this would be equal to the pKa plus, right, the log of the base part, which is our acetate anion, divided by the acetic acid, like so. All right, well, the log of 0.5 divided by 0.5, right, is 0. So the pH is equal to the pKa plus 0, at halfway to the equivalence point. That is why we get that value. So you don't have to run through this every single time if you just know that for a weak acid, strong base, halfway to the equivalence point, the pH is equal to the pKa. But we've proven why that is. All right, well, lastly, when we're talking about weak acids and strong bases, we can talk about how we want to determine our indicator. And remember that we need an indicator that is going to change colors, right, at the proper time. So the end point has to be close to our equivalence point. And we know that for a weak acid, strong base, right, we need to have the equivalence point will be basic. So thus, we need something with an endpoint that is also basic. We need something that will change colors when we have a basic pH. So choosing something with an endpoint of like 4 is worthless to us. We need to choose something like the phenolphthalein here that has an endpoint around a pH of 9. All right, so that ends what we're going to talk about for our weak acid, strong bases. Next, we'll look at strong acids, weak bases, finally.